2 of the preview chapter for Math 139, we're going to look at a couple of special cases of equations of lines, specifically horizontal and vertical lines. Let's start with the horizontal ones. As I look at this horizontal line, what I have labeled here for you is a specific point, happens to be the y-intercept, 0c. But look at all of the other points on the line. What would this point be? Well, x is 2, but the y value hasn't changed. It's still going to be whatever that c value was. And moving over to here, our x value is now 4, but the y value still is the same. It's still c. Same idea on the other side. This would be the point -3c. So what we're seeing here is a line where all the y values are the same. And for that reason, hopefully it's logical that the equation y equals whatever that constant c value is represents the equation of the line. X can be anything at all. Doesn't matter, as long as y remains equal to c. We can also think of this algebraically if we investigate what the slope of our horizontal line is. If you start by just imagining that, or remembering that we kind of started by defining the slope as the steepness, think about how steep this line is. Get that value in your head, and now let's do the math for it and see if we get the value that you're thinking of. To find the slope of a horizontal line, we think of it as rise over run. And as you move from one point to another on this line, notice that there is no rise. It doesn't go up or down at all. Or, I can also think of it algebraically as c minus c, the difference in the y values. The run, well, if I take x2 minus x1, I am going to get some numerical value, not 0. I'll use these two, so I'll go with 4 minus 2. And that's going to give me 0 divided by 2, or 0 for my slope. Hopefully that's what you were predicting, based on the idea that this line is as non-steep as you can possibly get. It's completely flat. If I use that slope that we just calculated, I can actually go back to the equation y equals mx plus b, and let's think about what that gives us for the equation of a line. We've just decided our slope is m is 0. And if I go back to my graph again, the y-intercept crossed the y-axis here with a y value of c. And so simplifying that, I would just get 0 plus c, or y equals c again. Exactly what we predicted before. So the equation of a horizontal line is always going to be y equals some constant value. We can make a very similar argument for vertical lines. If I look at the vertical line I have graphed here, and again I just said sort of generically it goes through some point C0, then every single x value on that line is going to have the same x value c that we started with. This point here would be c comma 3. Here we might have c negative 2. And finally down here, c negative 4. Because all of the x values remain the same for the entire line, it would make sense that the equation of the line is just going to be x equals a constant, x equals c. This one's a little bit more difficult to predict algebraically based on our y equals mx plus b equation because it doesn't really fit that. Here's the reason we can't use that equation. Let's think about the slope of a vertical line. Thinking of it as steepness, this is the steepest possible line you could ever draw. It's impossible to draw a steeper one. So what value would you assign to that slope? Would you call it a slope of 1,000,000? Well, that's really steep, but you could still draw a steeper one. a slope of 2 million, for example. It's actually impossible to write a large enough number so that we have this infinitely steep line. If we try to think of our rise over run, our rise would be numerical values. For example, I could say 3 subtract negative 2. But what happens when I go for the run is that I'm going to be subtracting c minus c. There is no run. This graph never goes left or right. And in this particular case, it gives me 5 over 0. But of course, it doesn't really matter much what's in the numerator. We've got a problem when we have a denominator of 0. You can't divide by 0. It's undefined. So, the slope of the line is undefined, which makes it impossible to plug values into the equation y equals mx plus b. Because our m is undefined. For that reason, it's not surprising that this particular equation doesn't fit our slope-intercept form, y equals mx plus b. First of all, m is undefined. And secondly, just think for a moment about b. Is there any y-intercept on this line? No, it never crosses the y-axis. So there's actually also no b value, if we go up here and think about that. So this one you're going to have to simply keep in mind that it doesn't fit the y equals mx plus b form. When you have an undefined slope, it doesn't mean that there's no equation for the line. It simply means that you have to keep in mind that with all x values being the same, the equation x equals that constant value is going to turn out to be the equation for your line. Let's do a few examples, finding equations of horizontal and vertical lines. In our very first one, we're back to that vertical line again. And I'm going to notice that the x-intercept here is negative 1, and every single x value on that line, no matter where I look, is going to be negative 1. And so, my equation is x equals negative 1. This is an infinitely steep vertical line, so the slope is undefined. In our next example, we're looking at a horizontal line. All of my y values here are going to be the same no matter where I look. And they're all the same as the y-intercept, 2. So it makes sense that my line is going to be y equals 2. In terms of the slope, I actually could do a y2 minus y1 over x2 minus x1 here, but it's really easier just to think of this perfectly flat line as having 0 steepness. So we get a slope of 0. In the third example, we have yet another horizontal line. Looks like the y-intercept on this one is negative 4. And once again, all of the other points on this line would also have y values of negative 4. So here's my equation. Y equals negative 4. Once again, there is 0 steepness to this line, so I'll write a slope of 0. And then our vertical line again, this one's got an x-intercept of negative 3, and all of the other points on this line all have that same x value of negative 3. So my equation is x equals negative 3. And because this is infinitely steep, I cannot assign a numerical value to the slope. We say the slope is undefined. One quick comment on this. Once in a while I get a student who likes to say there is no slope. And notice that that's a very confusing statement. What do you mean by no slope? Do you mean a zero slope, or do you mean the slope is undefined? So I would encourage you not to use that language, but to be very specific. Your slope of a horizontal line is 0, and your slope of a vertical line is undefined. This concludes a very quick section of P2. Join us next time for the third section of our preview chapter.